So I welcome you all to the second session of first day, and in this session, our research person is Professor AVHINASH Sharma. He is presently Pro VC at City University Punjab and worked as Director Engineering at CGC Mohali University from 1st November 2023. He earlier worked as Professor and former Principal, awarded as the Best Administrator, Maharshi Markandeeswara Engineering College, Maulana, Ambala, Constituent Institutions of Maharshi Markandeeswara, and now associated in NIRF ranking, NIRF Innovation as Nodal Officer and IIC President in Maharshi Markandeeswara College, deemed University, and QS Asia University ranking and other national international ranking process and NBA. Also Dean Faculty of Engineering and Technology and member of Board of Studies and DRC Committee for Research, former Director and Professor, Rajasthan College of Engineering for Women, which is a leading women's engineering college of the state of Rajasthan. And previously also Principal and Professor at Maharshi Markandeeswara Engineering College and Director Rajasthan Engineering College and Founder, Principal and Professor of Aditya Vedanta Institute of Technology, Agra. So in these introductions, I invite you, sir, Professor AVHINASH Sharma, sir. So now the session is yours, sir. Kindly share your screen, sir.
Okay, we are going to have a session today on the medical imaging techniques for the COVID-19 related diseases. As we already know that these kind of diseases has been very much troublemaking for all over the countries across world, and we faced major challenges in the year 2020 and again in 2021. And the fear of the COVID related diseases is not even gone today also. We are going to see many future pandemic situations where we may use the different technologies which are available, and specifically the medical imaging techniques. So these techniques which has been used during the COVID-19, and even in future we can apply these techniques in the healthcare sector with the help of various algorithms, even during the coding and everything we are going to explain in the session. So with my self, Dr. Tarkeshwar is also there. We had done a very good extensive research in these medical imaging techniques, and we are going to explain all these things to you, all the participants. So we are going to have a good hands-on session. So I request everyone that if you have your laptop available with you, so you can start some coding with us, and you can learn something new from this session. So Dr. Tarkeshwar, can you please elaborate on these topics again, please?
Thank you. Thank you. Myself, Dr. Tarkeshwar, I will be heading this seminar. So this nowadays, as sir explained, pandemic is may come in next anytime. So that's why we are taking a reference of COVID-19, and not only COVID-19, and we can take imaging technique and any other type of disease we can identify. Just we need to mark, and based upon that the trained model, we have a available trained model available online, and these models we can download. This is how we can save a computation. So as we proceed in this, so if I talk about, so you must have to have installed a Python on your machine. So in my case, I'm using Python 3.12, or any version of Python you can use. There is not a mandatory that the same version. Or if you are if you don't have a Python on your machine, you can go with a python.org and you can download first. So I will not download. I have already in my system, so that's why I will not be downloading. Just I'm sharing the link with you so that by the time being in the background you can execute. So this session is a completely hands-on session. I will be explaining this from scratch, and any ID you can use like a Jupyter notebook. In my case, I will be using PyCharm because I have developed all
Sir,
these
someone is asking that whether we can use the Google Colab or not.
anyone. Yes, we can use. So as I said, you must have a Python installed. Any platform may be remote or in the local platform. You can use Google Colab. No, because I feel good in the same, but I will be sharing the code and explaining. So you can use, you can just copy paste or you can type the code with me. So both are fine. So it does not matter. Okay.
Sir, kindly share the code in the chat box
Definitely.
so that the participant can copy and paste that one.
Right. Absolutely.
Sir,
So
at the same time, we will be taking some theoretical part also, that what are the various techniques and how they are incorporated in this coding. So it will go parallel hands in hands on session. So those who are having the laptops, they can directly practice it on their laptops, because we'll be putting the code as required in the chat box, and then they can simultaneously execute it also, sir. So this will be quite
Sir,
helpful.
good evening, sir. If
Yes, yes,
possible,
good.
can you share the documents in WhatsApp so that we can copy in that and we can do that one? Because only
Yes,
small.
yes, yes,
Thank
yes,
you.
sir. I will try to make it both the things simultaneously possible. Okay, no worries. No.
all right. Thank you. So, all right, let's proceed. So once you have all this environment set up ready on your machine, then everything will be fine. In my case, I will be using a PyCharm. And if you want to, if you are willing to use a Google Colab or any other platform, you are free to use. Because I have industry experience, so that's why these all the code is along written along with the comments, required comments. All right, so let's proceed. So in this research or in this, we have we are providing the necessary context that highlighting the global challenges of global COVID-19 pandemic. So it's a more importantly, we need to take some images. I have a repository. So this is the repository, online repository, from where I have downloaded some images. These online images are already available. You can download and you can put on your local machine so that we can find whether this particular image is identified as COVID-19 or any disease effective or it's a normal image. So let's proceed. So in this list, the key role of imaging, so we are applying the technique called image recognition from the diagnostic and monitoring. We are diagnosing and monitoring, which is immediately communicates the relevance of importance. So let's assume uh, you are or anyone, one of your somebody got one disease and got doctor required some attention on it. So it a doctor can identify or machine can identify with the help of prior images, and these images looks like this. I'll show you this what type of images we have. So this is the one. I have images called these one. Let me show you these images I have. So PNG images I have this one. So these type of X-ray images we have. So if you talk about in the first one, in this there is no spot is recognized. So that's why this is this image is completely neat and clean,
Sir,
normal.
these images are present in PNG file, no? In
Yes,
our
in the form
report.
of PNG file, because PNG files are good and low data, means you can say it require less amount of storage, and there is no pixel raster images available into this. It's a almost type of vector image. That's why we have selected PNG. Dear participants, if you are not speaking anything, please keep mute, and I will tell you some insight into this.
Adding to this, I want to tell you that PNG files are most suitable for the maximum kind of developed algorithm in Python.
All
And
right.
some of the images are not compatible. So I'll always use the PNG files. And I request all participants to please mute yourself in order to better understand the algorithms and coding.
So in this research, we are including total 443 sample files, or samples maybe more than that. And we have some pictures. Few are classified as a normal image, few are affected image, or some other type of disease. So here we are going to discuss about the roadmap, how we will proceed in this type of research. So let's take an example. So first, in the introductory, just now we have started, we are providing the context of COVID-19 global challenges, and once another one is answer the why medical care images is important. So these two things should be comes into your mind first, then only we can proceed towards the research. Then once you find the curiosity, then you may proceed with what is the role of imaging techniques, and finally it this road goes to the research. So this is the chart that's we are going to follow this chart. So what we have in this presentation actually. So especially if we talk about, first we need to identify the role, what is the role of imaging technique, and how we are going to identify them, and if once they are identified, whether they are classified correctly or not. So automatically error correction also available into this. Especially we can use two types of technique. If you talk about the basics of image recognition, we are using CNN or RNN. So now many researchers, they are very confused about which algorithm is good. So straightforward, I can say CNN is the best for grid-like structure. Means somewhere you have a pixel-based structure, grid-based structure, while RNN are designed for special data where order of information is matter. Order of information matters. So let's take some example of this. For CNN, like image recognition, video recognition, medical image. So obviously we are going with medical image. So that is the reason we have selected CNN on priority. And autonomous vehicle, in autonomous vehicle, we are identifying the images like a traffic image, a car image, or any type of images for recognition we can use. Even CNN is good for natural language processing. We call it NLP, because this is always giving you the fast response. On the other hand, if you and NLP is a very uh, diverse, and this is very gentle. you can use RNN or CNN. In both cases, it is giving you good results. All right. But if you talk about especially on the RNN, best RNN we can apply for speech recognition, time series database, or music composition. Okay, that is the reason. So we are going to use image recognition with CNN. So what is the background of this research, entire research? So this section served to remind the audience to unprecedented nature of COVID-19 pandemic by mentioning the unprecedented challenge for healthcare system. It is highlighting that this was the crisis on global scale that require a new or innovative approach for medical care. So why it is needed? So in 2020, we have faced COVID-19 and tomorrow new disease may come. So this type of exercise can help us to identify new type of novel disease, but we can name it later. So one question is coming. What is that? All right. So here we are selecting a data set, image data set, and this data set is already available on Git repository. I have already shared this Git repository. So you can go with this Git repository. This is the Git repository. Under the PNG, this is the repository. And if you want to download dataset, entire dataset along with the images, complete dataset. But I have my own everything. So I'm going to use CNN. So that's why my concern is only to use images, not this dataset. This dataset also available. This dataset freely available. You can use this. This is CSV file, but we are not using this CSV file. Each and every image have a certain record. All right, now let's proceed. So by mentioning the unprecedented challenges in healthcare system, it is highlighting that this is a crisis for global world. So in this set of stage, the next point which we intermediate new need of medical imaging, and doctors may be busy with other patients as well, and if they go manual image recognition or what is the problem in the x-ray, it takes a time. What if doctor will get the conclusion? So this is how uh, anyway machines cannot be that much faster, that much efficient like a human, but machines can help us, help doctors to find reach on certain conclusion. So this conclusion may help correct medication. So this background text positions the imaging as crucial tools that was not just helpful but necessary for navigating the complexity of disease from diagnosis of management. It provides essential why behind the entire presentation, making it very clear and outside technologies. So this is a flow diagram. We have proceeded and we have conducted this research long back in 2020 itself. And still this model is getting enhanced, getting trained and optimized, getting optimized day by day. And as much as you will provide the data, model will get trained by itself.
I interrupt here, Dr. Tarkeshwar. If we get the time, we will show our some of the models which we have developed and
Yes.
a few of the reference of some research papers which we have written for the what you can say better understanding of this pandemic related diseases and medical imaging technique. especially in the year 2021, that is the third phase, and then their future conclusion also. So that will help a great insight into these kind of models.
Yes, yes, sure, we'll do that. So, if you search about us, Dr. Avinash and Tarkeshwar, and if you search on the Google, and you will find many research paper and books we have published together, and articles, research papers. In the research gate, where you can find these all research related to uh, image COVID-19 recognitions. You can see these reference papers you can download. I'm sharing this one with you, so please download accordingly, and I will explain each and every research paper what we have published. All right, now coming to the uh, presentation. So especially what happens, this data in we have already implemented in our one of the project. So we are collecting data, medical sensors. We have implemented IoT, and as image is captured, immediately we are generating data, and based upon that, we are performing analysis image, as well we are storing data in the in MySQL. We are using MySQL dataset to store. So IoT devices, they are collecting data, sensing data and stored with the help of router switches. It is getting stored in one of the place. We have a warehouse, their data is getting stored, as you can see in the flow chart. So let's come back to the little coding. I believe many of you have already downloaded this one, and this is the link. I will be sharing this link with you just after this meeting.
Sir, please show the previous slide. 1 minute, sir. Please show that
Yes,
slide.
this one.
This one, yeah. Sir, hold 1 minute. Just I will note down.
Yes, please.
Later on, we will share this PPT on your
We will
chat box
share.
also. We will
Yes.
share it. You can take your PPT for all future reference. That is not an issue.
Or you can take a snapshot.
Yes, sir. I did the same, sir. Thank you. You share later on, sir. Please. Thank you.
Yes,
Okay.
thank you. So here, what we are going to use, so once we have installed library, so we have a NumPy. NumPy is a very common for numbers calculation, because binary data is image data in the form of 0 and 1 images. So that's why for number calculations is required. And TensorFlow is nothing but is a framework developed by the Google for image recognition or huge amount of computation. And then TensorFlow, we have loaded a model. Predefined models are available, because if we train our own model, it requires a lot of time. So that we don't want. So few already available models we can download and we can train them. So it will take, we can save time. And before processing any image, we require to resize image, or sometimes images may not be correct as per the standard. So automatically these images can be resized as well. Like this one, these all are images already filtered, but some images may be blurred, or maybe tilted, or it may be defected image like this one. So this image is not up to the mark. So this image can be cropped by itself. So image processing is required to fit these type of images in our model. So this is a completely automated model. So we have created one function called load disease model. By default, this model is available. Just we are install providing some some details like with the help of keras, one flattened layer, the image size we have provided because we are considering the left, right, and top three axis image. And for this one activation function, we are using ReLU and Softmax. ReLU and Softmax. So we have find the best results while we have combined ReLU and Softmax as an activation function. Activation function is nothing but which pixel should be passed as a correct one and which function which pixel should be dropped. So for that reason we have used. And once this is the definition of model, once this model we got in the system, then we need to compile, we need to prepare it, and we are using optimizer, Adam optimizer, and matrix cross entropy we are using. So and cross entropy will help us to segregate the data and then collect it at one place. So this is helping us to load conceptual model, and in case anything went wrong, it will raise exception. So the first function I'm sharing with you, so just you can copy paste, I'm sharing in the chat window. And
Sir, that load model we have to load, no? That h5 dot h5 file.
yes.
So that will be different path to
Yes.
your model dot h5.
No, right now we just instructed this type of model we are expecting.
Okay, sir. Thank you.
Thank you. So we have provided some, so this is long code. Some comment I need to delete. Okay, no worries. I'll do one thing. I'll share twice.
Sir, if any link is there, you can share that, no? Means instead of sharing, copy pasting link is
Right.
there. you can do it.
I will share the entire file.
Yeah, it would be better, sir. Means no errors will be there.
Okay, fine. That's
Yes.
true.
Thank you.
So I'm sharing the file. There is no chance of making a mistake.
We'll be sharing more additional link also for your future reference. So those particular links also you can try later on. We'll do all the other links also for your reference.
So what you have link provided in the GitHub,
So please share. It's already shared. Please check.
No, sir. Please listen. The PNG images are not getting downloaded from the GitHub.
Okay, I'm telling you, please. So please, everybody, please open the git cmd command. Just cmd, and wherever you are, just pass git space clone, and then put that link, the one I shared with you. So the entire repository can be downloaded like this. This is the command. So the entire command I'm sharing with you.
So Git is not recognized as an internal or external.
All right, no problem. If you do not have a Git, no problem. You just go with the Play Store or you can download Git. Git also very small software. Git download. So just search Git download, and this is the link. Very small software. You can click here and you can download and you can install. All right, so now let's proceed. So in this code, so in this section, the imaging went beyond the just a single use and becoming a multi-purpose tool for healthcare professionals. Doctors can use this tool for different purposes, not only recognizing a particular disease. As per instruction from the doctor, we can retrain again and again, and we can classify different diseases. So first, we need to, these are the 4 steps we have into this. First, we need to diagnose and confirm. So in this, we are providing a visual method. Just visually, we are watching this to identify and confirm whether the virus effect is available in the lungs, which is especially critical when lab-based tests are not readily available or took too long. So for COVID-19, report will go to the pathology lab and they will test, and it's a very time-taking process. So, and then accessing disease severity, what type of disease severity it is having. So AI can help, or this model can help the percentage of image, what percentage of affected image is there. So it is allowing doctors to see the extent of lung damage, inflammation, which help them understand how sick a patient was and determine the appropriate level of care. Then monitoring the treatment. So once the things are started, parallelly we need to identify whether patient is recovering or not. If recovering, then what is the percentage of that? So it is enabling the clinician or
It is
doctors
showing
to
this error.
uh,
After downloading Git and then putting in
uh,
command from this Git clone
okay, no
command.
worries. Do one thing, you can share your screen if you I can help you on this. Okay, whenever you are ready, you can share your screen. All right. So doctors can track the patient progress over the time and see if treatment was working by comparing the image results
Sir,
from
I have
different.
shared here.
Okay, let me stop this. Yes, I can see. So yes, the command is wrong. So just type here git space clone, git space clone, and then paste this URL. Git space clone, CLONE space, and now paste that URL. Same. HTTP get clone. Yes, right. Correct. Paste now. Enter. Okay, you don't have a Git. So open the browser, Google, and search Git download. Git download. This is a small software. You need to download first.
Sir, downloaded and installed also, sir.
Yeah,
Still
show me.
registering. Yeah, sir.
Then okay, then close this command prompt. Then close this command prompt and open once again. Close this command prompt. Yes, open it once again, and then definitely this command will work.
So is it git clone?
All right, shall I proceed now? All right. Okay, once then differential diagnosis. So differential diagnosis is helping to rule out other respiratory disease like one disease, pneumonia and COVID-19. If pneumonia and COVID-19, if I want to compare, then how much they are different. So the differential diagnosis also available or possible with the help of this type of image recognition. So it might be similar symptoms, ensuring the patient received the correct diagnosis and treatment. So this is the diagram for this. So first imaging technique we are applying and diagnose, confirm with the help of visual method and to confirm. And after that, assessing the severity. If patient is affected with the disease, then how much is the, what is the severity level? And then once we have find the, then we have to proceed with the monitoring treatment. So how fast patient is getting recovered and differential diagnosis. Parallelly, we are treating the patient with one disease and see parallelly another disease also identified. So this can help to identify other diseases as well. So it's nothing but it is able to find the difference between the one image to another image and how what is the percentage it is matching. And medical imaging becomes crucial tool for diagnosing, confirming COVID-19 infections. So across the world, this technique is being used and it is commercialized almost, and assessing disease severity, progression in the lungs, monitoring treatments responses, and ruling out other causes of respiratory illness. Right, shall I proceed? Now the best place is X-ray image. Chest X-ray image is the best way to diagnose. So in this, we are exploring the primary imaging technique. First, we will do the CNN and then we will apply the RNN. So according to my research, CNN is performing well because these type of images are grid image. So X-ray can understand known as the first line of defense. So use a small dose of ionizing radiation. And nowadays X-ray, some people can say, sir, X-ray also injurious for body. Yes, that is true. But here we are taking a light images, not heavy images. So obviously this is not good for health, but at least somewhat radiation it will affect. So chest X-ray images are focused on the first line of defense. It uses a small dose of ionizing radiation to create images of inside the body. The diagnosis and confirmation, then accessing the disease severity, monitoring the treatment, and differential diagnosis. Chest X-ray image is often used as a primary or initial imaging modality due to its speed, availability, and low cost, because it's available at almost all cities. That is why we have selected this technique. So chest X-ray images played a crucial role during the COVID-19 pandemic, especially early stage, for several reasons. What is the reason? First one is speed. Just you need to upload the X-ray image, automatically it can identify. And X-ray images, X-ray machines are available even small town, in fact some small remote areas as well, and it is a low cost. It is not in India. Government of India has announced free COVID test, but in this case it is not. That time this technique was very useful. Free vaccine, many things are provided. So chest X-ray images can perform and interpreted within the minutes, very quickly, not even a minute. And it is providing a rapid initial assessment of patient respiratory status. X-ray machines are widely available in the hospitals, clinics, making them accessible to the limited resource settings. So this is a diagram in X-ray image COVID-19. Now let's proceed. Hopefully everybody has set up the environment. If anybody facing any difficulty, please feel free to ask me. And at any point of time, if you stuck or if you lost somewhere, immediately you can read the comments. Comments are very important. And these comments are self-explanatory. So you will lose nothing. So first method is done, function is done. Next, we are moving towards the pre-processing of images. We understand there is the chance of images may be wrong. So that's why this code can resize images or make changes according to the requirement. Automatically, nothing is to do. All right, so first it will load image. From where it will load the image? So image path we will need to provide. From where it will load, we need to provide the image path. And what is the size we require? We require the image size is 224 by 224. If you increase, is your choice. So if you have a large images, you can select the images 224 by 224. So as you can see, this is the size. And if you want to measure, only this much of sizes we are considering. So you can see on the bottom side, the size of the screen, resolution of the screen. So many of the images are around 600 by 500. So this is the target size. You can change, you can resize, it's your choice.
Excuse me, sir. Sir,
Yes.
by reducing the size of the original image, won't it hamper the performance of the algorithm?
No. Yes, if you make a big one, we need to set the threshold for this. Like my image is very big, but you are targeting only small portion of the image. So there is a chance it may affect the accuracy.
Is there any threshold, sir? If the image size is 1024 cross 1024,
Then you can enter the entire complete size. Like I can make see if I change here, see here, if I change it, usually 500 by 500. So I can take here 500 by 500. I can take it. So it will take this much of size, 500 by 500. But
so it
maybe
will increase the
possible.
complexity of the program.
Yes, right. That's true.
So is there any threshold that up to how far the image size can be reduced?
75%. 75%.
Okay,
So
sir.
usually threshold is 75%. Whatever the size, width or height we have, so we are usually considering 75% of the image.
Thank you, sir.
75% to 80% maximum.
Okay.
And if you go up to 100%, that time some images may be small. So that time it will not take. It will take, but some black screen will come on this in the results.
Okay, sir.
Then image array. So image is nothing but it is a combination of pixels. And pixels, they are nothing but in the form of row and columns. So if you check the image looks like this, right? Any image looks like this. So any image looks like this. Let's say if I write A, then if I zoom it, and you can see the image how it looks like. So this is how image looks like. So these are known as pixels. If we have a high dense picture or high quality picture, then if you increase the resolution, then it require more computation. So it should be selected according to the computing power available. So that's why free of cost you can go with a Google Colab, but Google free of cost, free service, Google is providing only some small amount of computation. What if beyond that you may get a license, or you may to get a GCP platform license, then only they will allow you high quality computation. But in my case, I have a computer that is having 32 GB of RAM, so there is no issues into that. So I have enough CPU and GPU, so that's why no need to go on cloud, Google Colab. That is the reason I'm using the on my local machine. So 32 GB RAM I have. That is the reason. And this is a GPU. I have a 4 GPU. The good quality of GPU I have. That is the reason. It is better than the free of cost providing by the Google Colab.
Sir, please type in the chat box the configuration of the computer so that we can buy and we won't be depending on the Google Colab.
No. If you go to buy this much of configuration, it may cost more than 1 lakh in India. So especially you require, in my case, I can share my screen only.
Sir, means we have to, where we have to go if we are using PyCharm, where we have to go to set that GPU?
Yes. By default, just you have to call through the Python code itself. It will select GPU.
Okay, so by default only GPU it will install. If we
Right, by
download the
default.
Python and install it,
Yes.
PyCharm.
If your laptop or machine have a GPU
Supports, no?
driver, it require a GPU driver. If you have a
Yes.
GPU driver, automatically request will be passed to the GPU.
Then
So
only. If you don't have that facility GPU, then it can't be done, no?
yes, it cannot be done. So you can see somewhat code I process. It is request going to the GPU. And
Yes.
CPU is
Normally
known as,
laptops have a CPU only. GPU, then we have to buy a separate laptop which is supporting that GPU.
pardon, can you repeat your question?
Sir, we have the CPU, no? Means if we want the GPU support, we have to take that laptop, buy that laptop which will support.
Correct. And if you don't have, no problem. Existing computer itself will work, but it will take time.
Yeah. Thank you, sir.
So it's not a hard and fast rule that today itself you have to buy a new computer. No.
Yes, sir.
Existing computer can work, but it will take time in comparing to other computer.
Yes.
So I'm sharing a next method as well. So in this, what we are doing in this method. So the method name is which disease we are going to identify. So right now we have taken only 2 diseases, only one disease. One is normal or COVID-19 infected. So like this, you can put multiple disease. As much as you want, you can put. And whatever image is processed, received, we need to convert into the array. And this image must be processed in the sequence of binaries, sequence of numbers. So that's why flattening array. is needed. So NumPy will help us to process the each and every byte or bits. Is there any list available which images are disease or normal image? Yes, we have this. So if you go in the repository, where is the repository? Yes, this one. If you go in the
Sir,
repository and data set,
one small doubt, sorry. If you can paste the code in one this no,
it's
because
already
it is
shared in
very
the file already shared
where, sir?
in the same platform.
Where the PNG is there, no? So which
Yes.
we have to, which file is there in that?
No, I shared. Okay, no problem. I'll share once again the same file.
This Python file, sir, which you are
Yes,
showing.
Python file I'm talking about. The same file is already shared.
Yes, sir.
COVID-19 detection.
Okay, please share once again, sir. I missed out, sorry.
Okay, no problem. Please is sent. Please check.
Okay, sir. Thank you.
Thank you. So this is the list of who is affected or who is not affected. So this list I have in the form of CSV, and all parameters are there. Now everything is fine, then it will return the array of image. If anything went wrong, it will return the something went wrong in the image. If out of the memory or if image is very small, so in that case it will raise exception. Now coming to the recognizing disease. So one disease I have identified here, COVID-19. You can put multiple disease here. So process image. So whatever the binaries we have processed, so returning from the binaries, the same array objects we will pass here, and then it will check whether prediction is correct or not. If not, then it will check once again to predict. If any error, it will raise error. Otherwise, it will check once again. And then predictions means 0 or 1. So if something is 0, first array we are collecting whether person is affected or not. So predicted class. So predicted class, we have defined here class names. So we have two classes, either normal or COVID-19. And it will tell you whether confidence level, what is the percentage of COVID-19 effective. If something more than 60%, there is a chance, or more than 70%, there is a chance of affected image. So main program execution begins from here. And this is the function we have created on the top. This is the model creation. Model creation. And if model is okay, means model returns true, then it will load the image. So I have selected one image. So this is the first image I have selected, or I can select randomly. I can select many images. Any image I can select. And then it will search the same image on the required path. So this is the path we are providing. And we are passing this image binary to the recognized disease. And whatever the disease, it will return as a result. If anything goes wrong, it will return error. So let's try. So run this now. I have taken the first image, so it will check. It is getting trained. 1 DNN. This information is If you see this type of message, that means it's just a warning message.
Sir, I have one query. Is there any criteria which you have applied for confidence score that beyond that
Yes,
number?
more than 60% or 70% based upon the accuracy. Less. See, we
You have
cannot.
written somewhere in the code that
Yes,
criteria.
yes. Threshold we have mentioned. Threshold we have mentioned here. On the top, we have mentioned the threshold.
Excuse me, sir.
Yes.
I am Shivadathan. Can we run this code in Google Colab so that there we have GPU facility?
Yes, sure.
Okay, sir. Okay, thank you.
So simply you can copy this code and you can go to Google Colab. Google Colab, and simply you can copy and paste. So it's loading now.
But when I am trying to run on Google Colab, it's showing the images file error, sir.
Yes. So you have to upload a file first.
Okay.
Because you don't have a result. This file name you don't have. That is the reason.
Okay.
So I will upload some file. So this is a folder, right? So here I will upload some file. So this is a file. So I will upload some file. So I have files located in this location. So PNG file I have into this. So PNG file, any file I will upload like this. So this is a file name, and I'll copy this name and I will put it here. This one place.
Sir, do we need to put that data set here again?
No,
Whichever you have
not required.
Then
Not
only one file will be sufficient to run this code.
Yes, because model is already trained. Just we are uploading our new file.
Sir,
And
but
see,
where we have loaded that model? Means this question came to my mind.
Yes,
So
this one.
which point can you show we have loaded?
In this location, files. Can you see on the left hand side, files?
Yes, yes. So we
Yes,
have
and
to
just
first
click on the
download.
upload. You can upload an entire data set. All the images you can upload here.
Yeah, we have to upload, no? That means, and then we can run.
Yes, you have to upload.
So can we upload image one by one, or we can upload all the images at a time?
Yeah, at a time you can upload. Select all and it will upload it at a time only.
Yeah.
Okay.
So you can select like this. All images
Or we can
be
make
uploaded.
a zip file and then we can do that. It is
Yes, both are. See this, I have uploaded all the files.
Yeah.
Sir, excuse me, sir.
Yes.
Sir, what do you mean by pre-trained? So that is no need to train again, or it is already been trained. Suppose I use your file. I'm new to this. That's why I'm having this doubt. Suppose I got your code, and I got the path also to some image that I want to check whether COVID positive or not. So in that case, this code has to be, will it work just like that, or is there any training required?
Training is required, because training is required according to you. Training is required.
Okay.
But not that much level of training. Small training is enough. Like if I give you, if you are going a showroom to buy a car, okay. So if I say in the car you don't have a mirror, or is something you don't have that is not essential. So that you can buy later. So that is a part of modification, small modification. So you are just modifying the existing one by small modification.
Okay, sir.
And this model can be saved in one place as a single file as well. So same model can be reusable. I'll show you this.
Okay.
So same model is reusable again and again.
I want to add here on one of the point which has been just given, that is on your training question which you asked. Okay, so what happens that some of the models are already pre-trained. Pre-trained means what? They are able to provide some accuracy kind of result. But if you are adding some more features, in that case you need to redefine those particular things and you need to train your model again. So that will give you better results basically. And training of model is what you can say, it's a continuous process. You cannot say that you have obtained the 100% accuracy. None of the model which is available has given the 100% accuracy, and it is next to impossible. It is not at all possible that any model will give you 100% accuracy. So this is the way you have to understand this concept.
Okay, sir. So
Good afternoon, sir.
where this pre-trained model will be, sir. See, now I have opened this code. I have some few files to train by myself, and where will be the details of or the content of already pre-trained
Yes,
model?
we will be sharing. We will be sharing
Okay,
this.
okay, sir. Okay, sir. Thank you.
All right. So now this is the main code. But when we applied the only CNN with this, then how it behaves? Let's check. This model, what is the accuracy level is you are getting in this case. So CNN we have applied. So one of the participant was asking the threshold, right? So uh, we are going to implement the threshold. So here I have taken the 32 by 32, but images can be small or bigger one. So as per your image size, with the image size, we can modify. And how many images you are going to consider in a single batch. Why batching is needed? Because right now I have only 100 images. What if I will be having thousands of images, millions of images? What about billions of images? That time it creates a problem. So that's why in a first shot, we are assuming the 64 images will be considered. If you want to make a small chunk, you can make. It's your choice. So this code is completely modifiable. This code as well I'm sharing with you, CNN image recognition. CNN image recognition. This code also I'm sharing with you. Okay, then epochs. So as I told you, these are pre-trained models. So if I go with 50 epochs, then I believe even my laptop also will take around 15 to 30 minutes minimum. Okay, and it may require, but still there is a chance of overfitting. There is a still chance of overfitting. So to avoid this, we need to set the threshold of epochs. And what is the learning rate? We need to set. Dear participants, if possible, please mute your mic.
So participants, please mute yourself.
Yeah, thank you. And how many classes you are going to identify? Like in a previous code, I have to taken 2 classes. Either it is normal or maybe COVID-19. But here I'm taking 10 classes. Disease 1, disease 2, disease 3, disease 4, disease 5. And this is like that many diseases are possible. Okay, so we have a data set. This is a Cipher 10 data set. It's an already available data set. It will download it. And these numbers, I'm taking a 75% data set for training purpose or 25% for testing purpose. So we have selected the percentage. And out of that, how many classes we are willing to classify the model. So total number of 10 we are going to classify 10. And the training data set will shape level how much data set it is there. It will check each and every image will set. So let's run this so that you can understand better. So this model is getting started now. So data set is getting loaded. So now let's validate this. So first data set we have loaded around, it has collected a 50,000 records has been 50,000 record has been fetched, and this is taking this much of rows and columns. Training levels. What is the percentage of data set we have selected for testing shape, levels, and test data shape? And finally, setting up the augmentation. So, dear participant, what is augmentation in deep learning? Any idea?
Adding more data by rotation and reshaping the images, maybe scaling, rotation like that. Is it okay?
Yes, right.
To increase the
Yes, sir.
amount of data means medical, especially in medical field, the data is very less, no? So we can
Yes,
augment
that is the
and
reason.
increase the images or data set. Build the data.
Basically, augmented is using for increasing the number of data sets.
Yes,
Single image using number of times.
Fake data set. You can
Yes,
say.
sir.
I have one doubt that load data you have just written for explanation, no? Means that model is only that sequential model which you have built. That small
Yes.
model that itself is the model in
Correct.
your program, no?
Yes, that's true.
Okay, and sir, that you were showing about the criteria, no? Threshold criteria.
Yes, I'm coming to that.
Okay, sir. Yeah.
So I would like to make a little more clarity about data augmentation. So data augmentation is a technique. Is artificially we are increasing the size of data set to reach on the certain conclusion or to generate a huge amount of data set so that we can find a certain conclusion. So why it is needed why we are generating fake data set? Because if we have a less amount of data set, then there is a chance of overfitting. So overfitting, to avoid this problem overfitting, we are using augmentation to avoid the overfitting problem. So but when you are generating fake data, there's a chance of including noise. So which makes performance very poor because this data is completely unseen, and the data augmentation exposes the model to wider range of scenario it may encounter the real world, enabling it to learn more robust generalizable patterns. Okay, so that is why it is needed. So to avoid underfitting or to avoid overfitting problem. That's very good. Let's proceed.
Sir, I'm unable to run the program, sir. Can you help me?
Yes, please share your screen. Quickly, please share your screen. Yes, it's visible now.
Sir?
Yes. Yes. It seems your side internet is very poor because it seems your screen is stuck. I can see GitHub URL. No worries. If you stuck even after this presentation, also we can discuss. We have we will provide a contact detail as well. You can contact to the organizer. They will forward your detail to us, or they will allow you to connect directly. Okay, so please.
Sir, Tarkeshwar sir, if you don't mind, can you post your details so that we can contact you afterwards?
Yes, definitely
If
we'll
you
do
don't
that.
mind.
Yeah,
Because your explanation is very good, but the time constraint, it is not, it is
yes,
very limited.
yes, time constraint. Yes, that is
Yeah,
why
yeah.
I'm also trying to.
Yeah, your explanation is awesome, sir, actually.
Thank you so much, sir.
Yes, participant actually, like, that 1.5 hour is not very much good for coding and other, but still we have made this, what you can say, sandwich kind of session in which we have told some theoretical concepts as well as coding. So
Making workshop, very good, nice session, sir. Please kindly help.
yeah, we will definitely help you. We'll share some more content to this chat window, as well as you can go through some research articles. So many things are available, and the organizer, sir, uh, like, that we had, like, some little time. That is the reason these things are very much good for medical imaging and for your research also, but it takes time to understand each and everything, so it's time constant process.
Sorry for the disturbance. Avinash sir.
Yes,
Actually,
yes.
we have attended, some other FDPs. When compared to this FDP to other FDP, it is a more interesting and, enthusiastic. So we don't have time to interact. So that's what we are asking your
It
personal
happens.
contact, and
It
also.
happens. It happens. It happens. Let me tell you that right now you are attending a session with both an academic as well as a person from industry. So my intention was that I wanted to give the session, especially I requested my colleague Dr. Tarkishwar also, in order to provide some very interesting live examples on this concept. Okay. So as you understand that 1.5 hour session was not very much enough. So uh, definitely you can always, I have shared my number also, I have shared my email ID also. You can always remain in touch. Everyone is invited to put their queries on either mail, WhatsApp, any like, any type. And I am very much proactive. I'll try to respond every participant.
Thank you, sir. Thank you.
Thank you very much, sir, for your kind concern. Thank you, sir.
Thank you. Thank you.
Thank you. So now let's come back to the topic. So we are going to generate some augment fake data. So what type of fake data? From where we will get it? So let's check. So the image we have uploaded. So obviously, whenever we discuss about, let's see, one moment. I'll show you what exactly is happening in the background. I will show you. So this is my picture. Any picture I'll take. What is actually happening in the background? So see this. So this is the image, right? And I'll make a small one, little small, so that you can visualize correctly. So this is the one. Okay. So this is the image I have. So what we are trying to do, I can right here, rotate and flip. See this. So sometimes doctor also not able to understand the properly. So usually doctor is using a technique to rotate the image. So like 90 degree, some certain amount of degree, they can rotate. But how computer will do? So this is the, so 15 degree. So we have selected 15 degree. We are trying to rotate the image. So rotation range is 15 degree. So maybe left or maybe right from the specific range to check whether we are on the right direction or not. Then width shifting. So what is the, so earlier we have selected 225 pixel, maybe 10% plus or maybe 10% minus, because sometime may be possible the valuable insights is already out of the range. So that is the reason we are trying to collect 10% plus or minus. So left width 10% or height 10% we can increase. So this is how we are generating fake data and fake data from the original data, original image. And then image can flip. So image can be rotated, uh, flip as well. I'll show you how flip works. Flip. So flip this one, flip vertically. See this. This feature also available programmatically. Sometimes you took an image, but it is available in the upside down or left to right. So this type of things may be possible. Zoom range, sometimes image may not be clear. So 10% we are trying to zoom it. You can change this parameter. This code is already shared. So 10% I can zoom it and fill the mode. So whatever image, resulting image we found. So according to the strategy, we can fill the new pixel, created the transformation. Sometime may be possible. Some images was smaller than the specified range, but we are trying to increase the 10%. Obviously, you will get nothing. So fake pixels we are trying to refill from the nearest image so that we can approximately we can reach to the real image. So this is the place, and then train the data generated. So whatever data we have generated on, based on that we are going to train our model. So training, we are training our model, and then image data generator. This is a function used for batching purpose. No augmentation is already done. Why batching is needed? Because we have generated one image we have uploaded, but now we have at least 5 or 6 images, similar type of images. So that's why we require to process these images in a single batch. So batching is needed. Otherwise, your computer may run out of memory soon. So this is the explanation, written explanation is available in the comments. So please do not forget to read it. I'm trying to explain each and everything, but still maybe something I missed. So in such a case, you can go with the comments. Now, it require build optimize CNN. Obviously, CNN, whatever we are getting may not be perform well. So in such a case, we need to optimize it. How to optimize? Because we have generated at least 5 images, and in those images we are trying to predict multiple results, and which is closer to the reality it will produce. So that's why optimization is needed.
Excuse me, sir.
Yes.
Sir, more 10 minutes only.
Oh, okay, sure. Okay, so now models, a sequential model we are generating, and we are adding our layers, convolutional, two-dimensional, and once we have images, we are using activation function ReLU. ReLU is blindly you can apply. ReLU is always giving the best results, and batch can be normalized. So this is a sequence of max pooling. And finally, if something is goes beyond the normalization, then to regularize this, we need to increase the dropout. And then in the block third, so we have created this block 1, block 2, and block 3, and like that multiple blocks we can create. So right now we have only 3 layers, and whatever results we are getting, we have flattened. After flattening is done, we are getting one pre-trained model, and activation function is softmax. And finally, model we are going to prepare, we are passing the image, number of classes. So number of classes, how many we have taken? 10. And once it is ready, then it will compile the model. So compilation is model. So this is the model architecture you can see on the bottom side. So this is a complete model diagram you can see. It's already visualized. And then it start training. So I have taken 50 epochs. You can take less as well according to your requirement. You can take 10. Usually you will reach on conclusion 10 to 15 is a suitable threshold for training. Sometime it may require 20, but not 50 is beyond its range. You should not go up to 50. So finally, it will print the summary and then early stopping, value loss, how much loss is coming. So you can see in the first epochs, we are getting around 30% accuracy. We are getting 30%. And then we are getting 51, 59, 64, 68, 70, 72, 74, 75, 76. And still this up to 77% we have reached the accuracy. And how many epochs? Only 12. Only 12 we have reached, but we have reached almost accurate one. So or when it will complete 20, or you will reach on this required results. Now reduce LO, plateau, and monitor the value loss factor, patient, and verbose 1. And finally start training. Once model is starting training, so each and every epochs getting pass here. 50 epochs, and batch size is 24 at a time images. And finally it is evaluating. Once the training is completed, the model will train itself. It will evaluate itself, and it will give you the accuracy. So this is the accuracy we are getting. And finally, it will generate one comparison chart plotting history, training history. So according to the history, the accuracy is increasing, loss is decreasing. So it will plot a chart. So this file is already shared with you. And good quality chart you will see in this high definition chart. Once all this thing is done, this model will save. So usually models are saved with the help with extension called H5. But if you want, you can use any extension name for this, as it is your choice. But usually in the industry, globally we are storing in the form of .h5. All right. So this is a model, and now coming back to this small theory. So now, so typically findings, what findings we have found in this. So this is the one of the most common earliest finding GGO. GGO stands for ground glass optics. So appears hazy. So sometimes it happens that image is not clear and it sometimes feel like a glass because X-ray image can reflect some lights. So that is the reason. Appear hazy area on the X-ray almost like a blurry smudge. So these represent fluid filling the small air in the lungs, but not the exact full of consolidation. So this findings can be subtle and this often more easily seen on the CT scan. So this is a problem, but it is telltale the sign on chest X-ray image. So as disease progresses, the inflammation becomes more severe. The ground glass opticis can evolve into the consolidations. So this is more dense and solid looking, while white area on the X-ray, which increases that the air sacs are completely filled with the fluid and inflammatory cell. The optics and consolidations of COVID-19 often have a characteristic distribution. They tend to be concentrated in the periphery outer edge of the lungs and in the lower lobes in the lungs. So this pattern is crucial, distinguish feature from other type of pneumonia that might have more central distribution. So it was very common for disease to affect both lungs with opticis appearing on both sides of chest. So this is the diagram how the uh, analysis is being performed. In the consolidation on the chest X-ray image is one of the clearest sign of active lung inflammation or infection. So it is essential what happens when the tiny air sacs in lungs called alveoli. So that are normally filled with airs becomes filled with something else like fluid, pus, blood, or inflammatory cell. So this fluid filled state makes the lungs tissues denser, and because X-ray cannot pass through these dense tissues as easily as they passes through the air. So the affected area appears as a solid opaque white area on the X-ray image. So in the context of COVID-19, this finding was particularly significant because it indicated the propagation from the more subtle ground glass opticis to more severe form of pneumonia, often requiring more intensive medical care. So the diagram you can understand, I will be sharing this slide with you just after this. So it is a hallmark finding in the early stage of viral pneumonia, including COVID-19. The phrases here to does not obscure underlying the bronchial or vascular masking. So think of as hazy, faint cloudiness in the lungs, and same symptoms you may see someone who smokes. So you can still see the outlines of the blood vessels. In the X-ray images, you can see clearly, and bronchial tubes through the hedge, which is what differentiate it from the more solid, opaque appearance in the consolidation. So the reason GGO were less commonly reported in the chest. This is our finding compared to CT scan is poorly method of resolution. So X-ray image, that's why it is much better. CT scan provides a much higher resolution across sectional view of lungs, make, making it far more sensitive to these subtle has changed. One chest X-ray image, which is two-dimensional projection actually. So these findings can be easily missed or appear very faint. So in future, we have a plan to convert these type of images in 3D image so that we can reach on particular uh, findings or particular results conclusion. So however, the presence of was crucial earlier indicator of viral inflammation often preceding the development of full-blown consolidation. So bilateral and peripheral abnormalities. So usually you will see the abnormalities. What type of abnormalities may create a distribution? So bilateral and peripheral distribution of abnormalities. Images may be blurry or many types of problem may come. But this, if you keep on training a model, we can avoid this problem as well. So the bilateral and peripheral distribution of abnormalities was one of the most consistent and defining the characteristics of COVID-19 pneumonia on imaging. So this pattern helped to distinguish it from other type of pneumonia like bilateral or peripheral. So this means bilateral means disease affected both lungs, bilateral. So it was just a single and isolated patch of inflammation in one lung, but rather a more widespread process involving both sides of chest. So this describes the location of abnormalities, the ground glass opacity GGO and consolidation were typically found in outer region of lungs close to the chest wall rather than in the central area near the heart. What are the limitations? Obviously, we need to think about limitations. Lower sensitivity. So a chest X-ray image is simply not as sensitive as a CT scan, and the subtle has ground glass optics, the characteristics of early stage. So we are going to perform these type of tests on CT scan as well. Or the same code will be applicable on CT scan because more detail you will find on CT scan and often too fainted to be seen on X-ray. So leading to the false negative. So it was very common for the patient with the negative chest X-ray image have a significant finding on the follow-up CT scan. Lack of specificity, so we cannot find the exact point. So severity maybe affect around 10% if maybe sometime maybe 70%, but it can tell you 60%. If in case sometime it's a 70%, it can tell you 80%, 10% plus or minus we are considering into this. So if something we got a 50 or 60, so that means it is a type side of positive side, COVID positive or any disease positive. Okay, may not show early stage disease. Compute CT scans like a computed tomography known as CT scan is a better, giving better results. So organizer is not allowing me to go further. So we have to conclude the session. This slide I will share with you. This is our findings. Thank you, participants. These are the references of our paper we have used. If any questions, dear participant, you may ask me.
Sir, could you please put some light on any novel research topic on this medical imaging, because nowadays there are many papers based on medical imaging, but sometimes they are confused. Everyone has done some work and they have got 90%, 99% accuracy. So is there any idea can you share with us so that we can work on that novel problems?
Yes, definitely. So nowadays, let me open the notepad. Yes. So nowadays, federated learning for privacy, preserving analysis. So this is the hot topic nowadays. You can work upon it. Another one, unsupervised and self-supervised learning. So you can work on this.
These are
And
related
obviously,
to medical imaging, sir?
yes. Generative AI for image synthesis and augmentation. You can use my mistake. Let me correct this spelling.
So in addition, I would like to tell here all participants that when if you want to work on some medical imaging technique, so first of all decide that on which kind of disease you want to pursue your techniques of applying the what you can say your uh, algorithms or your models. Okay, accordingly, if you are associated with any organization, university where you find that there are some healthcare related institutions or some medical college, if you are having, okay, then you can get yourself associated with one of the domain person from your respective institution itself, because the things which we have developed and we have shown to you is basically outcome that we have associated with many medical hospitals, from where we can ready-madely obtain the different images. Okay, some of the images which has been taken from Google itself, but during our model training, we have taken many images, many from the real-time data sets from the medical colleges, which may be some private medical college or some government medical colleges both. So these techniques which has been shared with you and the current topics which has been shared with you by Dr. Tarkeshwar are the most appealing. So if you have your further interest in working all these things, then you can show your interest, okay, to us, and we will definitely guide you in future.
Thank you very much, sir, for this guidance and the positive support you have shown to us.
Sir, one more topic I want to add. Just a suggestion. I'm also doing my PhD, and there I could found like you can use also multimodal AI, which is very
Yes, that's true. Yes.
recent nowadays. So it can be done. And sir, I am also doing in research in TB diseases. So I would definitely require some guidance from you. So I will contact you, sir, later on.
Definitely, sure. We will
Okay, sir.
feel good if you contact. Thank
Okay,
you.
sir. Yeah, thank you so much, sir. You will just share your email ID at the end session.
Yes, sure.
Okay, sir.
Avinash sir will share, or a presenter will share with you.
Actually, participants have given the email ID as well as WhatsApp also. Most of the research which we have done, me, myself and Dr. Tarkesh, is a joint research. So you can always feel to contact me also. Okay, and we are in what you can say joint collaboration research, and definitely we'll help. Okay, that thing has been already shared with you. Every in the
Okay.
chat, it has been shared.
Okay. Thank you,
Any other
sir.
question, participants?
Any other queries? I think no. So in this session, here we'll wind up. It's a very good session and very interactive. And it's the first session that Dr. Tarkeshwar is showing the coding part. That's a hands-on, and many of the participants are practicing that one and also asking the questions regarding this. And lastly, the participants are very much interested, so that they're asking the future aspects of the medical imaging research, all these things. And Dr. Tarkeshwar and Professor Sharma is also giving suggestions about the federated learning, unsupervised collegiate learning, and expression Y and multimodal I. But most of the thing that most of the participants are asking about the how we know that this diagnostic tool is good for the diagnosis purposes. I want to mention that there is a start guideline. You may search that. I also share in chatbot that chat of the Zoom that there is a start guideline. So according to start guideline, if your method gives that much of the result, then whether it is good, very good, or excellent, that will support. Another thing is that most of the participants are asking about what is the current trends of the research. First, you go through the many recent research paper, then see what is the lacuna behind it or what is the limitations, all these things. Then you yourself search, and according to the availability of the data set, that is more important. And if you have the collaboration with that as Sharma is suggested, that collaboration with the medical colleges, yeah, any type of the that medical college, private medical college or clinic, whatever it may be. So the most recently I can suggest that there is women related cancer. You go for the women related cancer, means cervical cancer, that is ovarian cancer, breast cancer, like this. These are very right now means going exploring topic, and that is one is federated learning and another one is multimodal imaging. Multimodal imaging means there is you may fuse the features extracted by the deep learning that models you can use, and by doing this so you can fuse the features, that means deep features of the more than one or two models like that. Or multimodal means you can suppose ultrasound and another one is CT scan or CT scan with X-ray, and again you can also doing fusing with that the clinical data sets of these things. Anyway, this is a very nice and interactive session. Thank you. Thank you very well. And I especially thanks to Professor Sharma that he makes this session very excellent. Thank you, sir. Thank you, Dr. Takeshwar.
Thank you.
So,
One of the participant asking question why we cannot use MRI images. Yes, sir. We have already trained our model on MRI images, but that data was proprietary. So for particular organization, we have received data set and we have worked only for them. So, but that data set we cannot use publicly, like in front of you. I cannot use that data
yes,
because we
yes,
have a certain
yes,
constraint on that.
yes.
Consent we require. So that's why I'm using here open data set and GitHub data set public repository we are using. But same application will work as it is on CT image or MRI images. So no changes are required in the code.
Okay.
In further, if you require our support, we are with you.
Okay, I will share the email ID of the Professor Sharma. Okay. Thank you. Thank you, sir. So
Thank
in
you.
this way, so today all the systems is wind up, and tomorrow we'll again meet at 6 p.m. Thank you.
Thank
You may
you.
leave now.
Thank you, everyone.
Thank you, sir.